In this lecture, we'll discuss about the introduction to sequential circuits. The sequential circuits are two types: synchronous sequential circuits, asynchronous sequential circuits. First, we'll see the definition of a sequential circuit. The coming output of a sequential circuit de depends on the existed output and the present input. The existed output is also called present state of the circuit, and compared to coming output, this present state is the previous output. Okay, so here we can see the equivalent circuit of a or block diagram of a sequential circuit. It contains combination circuit plus memory elements with feedback. So combination circuit plus memory with feedback become a sequential circuit. Okay, suppose if this memory element is a latch, then latch nothing but gated latch, then this sequence circuit become asynchronous sequential circuit. If this memory element is a flip-flop, then this sequential circuit become synchronous sequential circuit. Okay, see here for combinational we are applying input, and here we are taking output. The same output we are feedbacking to memory, and to the memory we are applying clock signal also. This memory output again we are connecting to input of combinational circuit. Okay, so if this memory is working with levels, then it will become latch, gated latch. If this memory working with edges, then it will become flip-flop. Okay, so the examples for asynchronous sequential circuits: a sequential circuit made with latches, and whatever the sequential circuit contain flip-flop, those all are comes under synchronous sequential circuits. For example, registers, counters, state machines, these all are synchronous sequential circuits. So we are using memory elements in sequential circuits. That memory element can be gated latch or flip-flop. Okay, so these gated latches and flip-flops are basic memory cells or basic memory elements. They can store 0 at one time and 1 at another time. So they are storing two different bits. That's why these are called bistable elements. Okay, generally we construct non-gated latches with NAND gates and NOR gates. We don't use NOT gates because NOT gate contain only one input. We cannot give feedback because there is no other input, and we don't use undo or XOR XNOR also. Okay, these latches and flip-flops both contain gates only, like combination circuits, but because of feedback nature we are getting memory nature. Okay, so synchronous sequential circuit means we can see the change in output, or we will get the output only at a particular clock edges, either positive or negative. Asynchronous sequential circuit means we can see the change in output, or we can get the output at any instant of clock level. Okay, that is the meaning. So here we can see one diagram to understand the exact difference between gated latch and flip-flop. Here I taken D gated latch and D flip-flop comparison. This top diagram is about D gated latch. This below diagram is about D flip-flop. These diagrams are called timing diagrams, timing waveforms. Okay, so this latch working with positive level, this flip-flop working with positive edge. Okay, here I am giving clock. So this is the positive level duration, and this is the data input. We know D flip-flop or D latch produce same output as input. Okay, so during this positive level duration, whatever the data input, that will come exactly at the output. And here positive level duration is ending, and here the data input is high. This same high will continue for this negative level also. See, here it is ended with high, that same high it is continuing, so it is holding, latching logic 1. Okay, now again here positive level started. In this positive level duration, whatever the data input, that will come exactly, and here it is ended with low. This same low will continue for complete uh, this negative level duration, so it will hold to logic 0 here. Okay, so only this is from here to here, this is the complete cycle. Only in the half cycle we are able to store. So this is about latch, gated latch. Now we'll come to flip flop. Okay, so this is positive edge, and here the data input is high, so output also become high until coming positive edge. Until coming positive edge, whatever the high it is there, that same high will continue. Okay, now again here second positive edge, here the data input is low, this same low will continue until next positive edge. Okay, this is the behavior of a flip flop. So we take in same clock, same data input, but output is different compared to gated latch and flip flop. So here in this complete duration of full cycle we are able to store. This is high means it is set, it is storing 1. So that's why flip flop is a full cycle storage element. I hope in this diagram you can clearly see the difference between gated latch and flip flop behavioral with help of this timing diagram. Okay.